Hello, ma'am. I'm going to talk about the graph in data structure and algorithms. Graph are the fundamental data structure that allows us to represent the relations and the connection between different entities. So, graphic terminologies, vectors and edges and adjacency. Vectors is node and point that represent the individual element in the graph. Edges connection or lines that link to vectors representing a relationship between them. Adjacency describing vectors that are directly connected by the edges. Signifying direct relationship. Type of graph: direct and indirect and weighted. Direct edges, directed edges have a direction representing relation with the order. Unordered edges have no direction representing a relationship without the order. Weighted edges have values assigned to them representing the strong or cost of the connection. Graph representation graph rep- representations, adjacency matrix and adjacency list. Adjacency matrix uses a two-dimensional array to store edge information that adjacency list uses list to store vectors and the connected edges. So adjacency matrix, a two-dimensional array representing a edges connection between vectors. Adjacency list a list of vectors each with the list of its connected edge. Deep first DFS mean deep first search algorithms, and that we're going to like DFX explores the graph by going deep into a branch before exploring other branches. Efficiency is searching for the goal node and examine all node in the connected component. Start vectors. Choosing start vectors in the graph to initiate the transfer travels travels. Explore the branch traversing through the connector vectors going deep into a branch before exploring other branches. Backtrack when all connector vectors in the branch are explored. Backtrack to the previous vectors and explore another unexplored branch. Repeated connect and travels the graph exploring all connected components until all vectors have been visited. Breadth of first searching algorithm. BFS BFS exploring a graph level by level, visiting all vectors at the same distance from the starting vectors before moving to the next level. Start of the visit. Begin at the starting vectors and mark it as a visited. Exploring neighbors. All the unvisited neighbor of the current vectors and add them to queue. Unqueued and repeated. Unqueued vectors from the queue, its visited, its unvisited neighbors, and adding them to a queue. Repeat until the queue is empty. Shortest path algorithms. Uh, what is this? Dijkstra and Bellman-Ford. Dijkstra algorithm finds the shortest path from the starting vectors to all other vectors in the weighted graph. Well, Bellman-Ford can handle negative edge weight. Like these are the examples of these are the method of the Ajastas and Bellman-Ford. So, next slide is minimum the spanning a trees, crucials and Prim's algorithms. Kushal and Prim's algorithm find the minimum spanning trees of graph while counting all vectors with the list totally edged weighted. Kushal greedy algorithm that sorts the edges in the ascending weight and adds them to the tree. If they don't create a cycle, Prim's greedy algorithm that sorts the vectors and repeatedly adds the edges with the smallest weight that connects vectors in the tree to vectors outside the tree. Application of graph, social networking, routing, and recommending recommendation system. So this is the thing we used we will we all implement the graph and the instruction in social network. Social network is responding a relationship between the users, analyzers, user behavior, and discovering communicating. Routing mean finding optical routes for transposition, net traffic, and resource allocation. Recommendation system recommending items or content based on user preference and past interaction. Conclusion and key takeaway. Graph here, virtual data, the gas is graph for versatile structure used in various application. Understanding the graph terminologies, representations, and algorithms is essential for tracking complex problems in computer science and related to this field. Thank you.